Alright guys, let's start. Is the dx operator actually in powers of x, or it should be in front of x? This integral is based on the concept of product integral, which is a multiplicative aspect of integration. Just subtract 1 and add 1 also. Now we can actually solve this term using a simple concept of limits. Let me show you what is that. There is a concept, limit h tends to 0, x raised to the power h minus 1 over h. This is equals to log of x. How do we prove this? Using L-Hospital's rules. Let us try to prove this. X raised to the power h minus 1. When h tends to 0, x raised to the power 0 is 1, 1 minus 1 is 0, and in denominator it is already h, that means 0. So it is of the form 0 by 0. When the limit is of the form 0 by 0, we can apply L-Hospital's rule. So we can differentiate the numerator and denominator separately. So differentiation of numerator will be with respect to h. Note that this is a changing variable h. We need to differentiate our term with respect to h. So differentiation of x raised to the power h is x raised to the power h log x minus 0, because differentiation of 1 is 0, and differentiation of h is simply 1, and limit h tends to 0, of course. Now this is equals to, now let us try to apply the limit h tends to 0. So x raised to power 0 is simply 1, so log x minus 0 over 1 is log x. Now what is the purpose of using this limit in this integral? Let us try to apply it. So we have x dx equals x dx minus 1 plus 1. Okay, now note that dx means very small change in x. Now we need dx in front of our integrand. How we can make it? Like this. We can divide it by dx, and now we can put an extra dx in front of the integrand, plus 1. Now this is the integrand. Now this is similar to the limit definition which we have already discussed. Let me show you how. See, dx means very small, so we can rewrite it like this. Limit delta x tends to 0, x raised to the power delta x minus 1 over delta x. We are not touching this dx because we need after all 1 dx in front of the integrand. Now this whole limit, let us take the limit first, which is limit delta x tends to 0, x raised to delta x minus 1 over delta x. This limit resembles our previous limit, so this thing will be what? If you are having difficulty in understanding delta x, you can replace delta x with h. like this, h and h. Now this whole limit is log x, so we can say this is equals to integration of log x dx plus 1. And now we can integrate this log x using by parts. So assuming 1 here, now make it this v and this is u, and by parts rule says that integration of uv dx is equals to uv dx minus du by dx integration v dx. So this is first log x as it is, integration of 1 is x minus integral differentiation of log x is 1 over x times differentiation of x, differentiation of 1 integration of 1. Now integration of 1 is x dx plus 1 equals x log x minus integration 1 dx plus 1 equals to x log x minus x plus c as a constant of integration plus 1. So that is the answer. We can replace c plus 1 as another constant, c dash. So x log x minus x plus c dash. That is the answer of the integral.